there, I'm Andrew Brown. Welcome to the series Real-Time Music and Sound with Pure Data. In this episode, we're going to be looking at how to create a drum machine. A drum machine, of course, is just a sequencer which is playing some drum or percussion sounds. And in previous recent episodes in this series, we've looked at sequencers, so this is a continuation of that. Let's talk a little bit about drum patterns and how they're structured so that we can think about how we're going to organize this particular patch. When we see drum patterns, you often see them in these kind of matrices like this, with each of the different instruments listed along the y-axis and then along the x-axis. There's steps in the sequence and when they sound or they don't. So we could implement this by having a number of tracks or a number of sequences running, one for each part. But what we're going to do this time is to take a sort of a simplistic view of this and look and see when instruments play by themselves, or sometimes they play in combination. And we're going to distinguish between when an instrument plays by itself and when it plays in combination with different numbers, so that we can simplify the sequence organization. The other simplification we're going to use in this particular example is that we're only going to consider the kick drum, the snare drum and the hi-hat, and the combination of those three. So let's have a look and see how that all works. What we're going to do is to use an array to store the sounding instruments along 16 steps in a 16-step sequencer. So we're going to create an array to store the data. I'm going to call it steps. It's going to be 16 steps long, 16. So here is our array. We need to change its range. So it's 16 steps long, which is fine. Its range, however, is going to go from 6 down to 0. It's going to be 7 steps because that's going to allow for all of the combinations of instruments that we've got. So let's think about that. This is our drum pattern is going to look something like this, with different steps having different values from 1 to 16 or 0 to 15. So what we're going to do is to organize the numbers from 0 up to 6 to stand for different combinations of drums, and it's going to look a little like this. When we have a value of 0, we're going to say that is equivalent to our kick drum. When we have a value of 1, we're going to say that's going to be a snare drum by itself. A value of 2 is going to equal the hi-hats by itself. And then we get to combinations. So when we have 3, we're going to make that equal to a kick and a snare. When we get a 4, we're going to make that equal to a kick and a hi-hat. When we get a 5, we're going to make that equivalent to a snare and a hi-hat. And then when we get a 6, we're going to make that stand for all 3 instruments playing together. So this is at the heart of what we're doing. In order to write to this array, we can draw manually like I just did then, but we can also use the array with set command to set different values. We tell it the array to write to, and then we pass it a message with all of the values. So we're going to use these values from 0 to 6. So for the minute, let's just do something which shows us all of those. 0, 1 should get us 16. Maybe we need one more. It's like 15. There we go. So we can use this kind of technique to specify an array. We'll just use this particular one which moves through all of these combinations as our test case. Alright, so now it's time to build our sequencer. As I mentioned, we have built a number of sequences in this series before, so I'm going to use some preset processes that we've used before. This is, first of all, this part of a counter. So a sequencer needs to count through the steps from the beginning to end, and we use a modulo to loop that around, and this f+1 is an incrementer or a counter, and we've got a metronome to control it speed. So this particular sub patch will take a toggle to start and stop it, and it will take a number to represent the beats per minute. So we can turn that up to some value. Then we want to be able to visualize what step we're up to, and so we'll use a H radio object in order to do that. We know that the maximum number we're going to have is 16, so we'll set that to 16. So now, there we go. We have our thing. We can change the tempo, and our step sequencer is kind of basically underway. So what we're going to do is use the values for the steps to read out of our array. So we can do that with the array get command, and we tell it the array to read from. The array is called $0 steps. Another thing that we can do is that will go in there and tell us to read from that particular value. The get function in array gets all of the remaining elements, but we can tell it to only look at the at one element at a time by passing in the value of 1 in this middle inlet. And that will help us out in some maths that we're going to do afterwards. So here we get the values from the array, and we can just see those coming out. And of course this counts up. If I mess with that array manually like so, you can see that we get different values. Because some of these values are floating point values, we need to make sure we round those off. So to do that, we say plus 0.5 and then use an int to truncate the values like so. You'll see that when we put a number box after that, we get integers, whole numbers. Okay, so that's all good. Now what we need to do is to be able to distinguish between these numbers and pass them to the appropriate instruments. To do that, we use the select command, and we select between all of these different values. And the select object creates a number of outlets for each of those outlets. So it means that 0 will come out there, 1 will come out there, and this is the way in which we can distinguish between the values. So now we need to have instrument sounds. And again, in earlier parts of this video series, we've been looking at subtractive synthesis processes. So we're going to just use some prepared subtractive synthesis drum kit. So here's the kick drum, and this is the algorithm for that. Fairly straightforward. There's just an oscillator which has a descending pitch line, and then an amplitude envelope also created using V lines. So we want this kick drum. 0 is going to trigger the kick drum, so we can select that. The next one that the kick drum is triggered is the third outlet, 0, 1, 2, 3. So we connect that. It's also on 4. So we connect that, and it's also on 6, so we connect that. Then we can do the same for the snare drum, and again we've got a similar patch for the snare drum. If I open it up, you can see it. There's some noise, which has got some filtering done to it, and then an oscillator which is turned down slightly, and then an envelope to give it the right shape. And so the snare is by itself on outlet number 1. It's with the kick on outlet number 3, and then outlet number 5 with the hi-hats, and outlet number 6 for all of them. And then we can do the same for the hi-hats. And again, I've got a sub patch with hi-hats, a pretty similar thing to the snare. We've got noise coming out here, although we don't have an oscillator in this particular case. So it's really just high pass filtered noise with a quick amplitude envelope, and I've got a bit of randomness in here to vary the velocity. So the hi-hats start first by themselves, outlet number 2. Then they're with the kick and outlet number 4, 0, 1, 2, 3, 4. And they're with the snare in outlet number 5, and then they're with everything in outlet number 6. Okay, so numbers are generated, they get passed to the appropriate instrument. Each one of these sounds has a right inlet which controls its volume. So I'm going to put these in here to control volumes for each of those 3. And then they need to go to a DAC to go out. Let's just make that a little bit neater and tidier. Just use plus tilde object there just to mix them together. Oops. So kick, snare, and the hi-hats, and they can go out to both channels like so. So if I start this, then I turn the volume up, make that go, turn the volume for the kick up. There it is, the kick, and then add the snare, and add the hi-hats. So this is just playing the sequence here. If I change the array, then we change the pattern which is being played. And in a sense, there we have our drum machine. In order to get some patterns done, we can go back to that pattern, which is kind of nice because we can use this technique as a kind of preset. And I've created a few presets earlier. Let me just paste those in. I'm going to put them all over my face, but that's okay. So these here are presets based on some of these patterns that we showed earlier. So let's get it playing and then click on some of these. Increase the tempo, slow it down, try another pattern. So you can create your own patterns, of course. One thing which is worth mentioning is that you might notice that some of these, there is the number 10. If I move this down a bit, you can see right at the top here, the number 10s are right up off the top of the array. I've used 10 as a substitute for a rest. We're not mapping the number 10 to anything, so it's essentially being ignored by the select, so that functions as a rest. All right, have a go at that, see what patterns you can make with your drum machine, and I will see you in another video.